All right, as we begin day 6 for lesson 3.6, we're going to continue with our lessons about angles. Yesterday was geometric, but again, it had some algebra wrapped around it. Today will be a little bit more geometric, not so much algebra. So we have some terms that you're going to want to focus on today and make sure you study. I would say that vocab will be actually more of a role today than any algebra. So we will start off with a little formula and a little property that explains interior angles. An interior angle is an angle that exists on the inside of a polygon. And for polygon, feel free to just interchange that for the word shape at this point. Not always, but for now, that'll be okay. The sum of interior angles is based on how many, and this won't be a big surprise here, how many triangles. Just like we did for area, can be created inside the polygon by connecting vertices. And when we say connecting vertices, there's a triangle, there's a triangle, and that wasn't very good. There's one. So we have 1, 2, 3, 4, 5. So we have 5 triangles. And with 5 triangles, that comes from 1, 2, 3, 4, 5, 6, 7. That comes from a 7-sided polygon. So a heptagon. So 5 triangles in a 7-sided polygon, and that will always continue to be the pattern. If we were in class, we would have done an activity to kind of prove that. But the number of triangles is always 2 less than the number of sides. And something might know back from prior math classes, the interior angles of a triangle add up to 180 degrees. So if each of those 5 triangles is 180 degrees, it would be 180 times 5. Or if we use the formula, 180 times, this is the amount of triangles, 2 less than the number of sides. So S is going to stand for the sum of the angles. Sum of the angles. This is going to be the number of sides. So for a heptagon, we're saying that n equals 7. So S equals 180 times 7 minus 2, which is 180 times 5. So S equals 900 degrees. Notice how it was disguised which information was given, but it was an n value that was given. I can give it to you the other way here. So for number 2, it says the sum of the interior angles. So now they're telling us this is what S equals. We want to know how many sides. So they're asking the question backwards. So 3600 equals 180 times n minus 2. Now I'm going to have you solve this maybe in a way that you would not have instinctively. I know we're kind of primed to distribute every time we see this, but we're trying to get n by itself. If we distribute, we're going to put the 180 on that end. So eventually we're going to have to divide by that 180 to get it off of that end. Why not just divide by 180 from the beginning? And we're left with 20 equals n minus 2. And now we can just add 2 to both sides. So it's a 22-sided polygon. Just to see what happened there, that canceled out. Since 180 was being multiplied to this set of parentheses, when you divide it away, it leaves that parenthesis open and we're not needing the parentheses anymore. Okay, so when two lines intersect, 4 angles are created. When that happens, we have some properties that show up. Any two adjacent angles, remember adjacent angles share a side. So an adjacent angle would be like angle 1, and they share a side with 2. So these are adjacent angles. But 1 and 4 are also adjacent angles. 2 and 3, 3 and 4. So any two adjacent angles are supplementary. Meaning they add up to 180. Remember, we have to be able to see that. Angle 1 plus angle 2 equals 180. Angle 2 plus angle 3 has to equal 180. Three and 4 has to equal 180. 4 and 1 equals 180. Notice how those arcs that I made, they do overlap, and there is a little bit of redundancy in there. The sum of all 4 angles is 360. It'd be a full circle. So if 1 and 4 add up to 180, and 1 and 2 add up to 180, what does that say about 2 and 1? They have to be the same thing if they're both getting added to 1 to equal 180. We call those vertical angles. And those angles are congruent. So that means angle 4 is congruent to angle 2. Angle 1 is congruent to angle 3. They're congruent, or they're equal in measure. Now, what if we have two intersections? Two intersections, and those two intersections are parallel lines. So a line that crosses or a line that intersects two parallel lines is called a transversal. We can think of this several different ways: a bridge going over a river, a bridge going over an interstate. So if this is the water, and this is the land, and this is the bridge. I'm going to put some identifiers in here. So 1, 2, 3, 4, 5, 6, 7, 8. So these are the things that you guys will need to study the most out of this section. The angles on the outside of the parallel lines. The angles on the outside of the parallel line. So the angles in the green, the angles on the shore, the angles in the grass. Those are exterior angles. Angles on the inside, the ones in the water, are interior angles. And I also want you to notice this set of 4 is very similar to this set of 4. In fact, they are going to be identical because since these are parallel, they have the same slope. This transversal is going to intersect them at the same angle, basically making a mirror image. So I literally can take 2, 3, and 4 and set them on top of 5, 6, 7, 8. That idea is what we call corresponding angles. They're angles that are in similar positions but in different intersections. So angle 1 is corresponding to angle 5. Therefore, they are congruent. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. So if I know the top 4, I know the bottom 4, essentially. Some other properties that show up are when we look at the alternate interior angles. So we know the interior are in the blue. Alternate means that it's going to crisscross the side of the bridge. So 2 over to 8. So it switches sides of the river and it switches sides of the bridge. So it crisscrosses 2 and 8, 3 and 5. And we can think of it this way as well. 1 and 3 are vertical. So we know 1 and 3 are congruent. 1 and 5 are corresponding. So if 1 is congruent to 3 and 1 is congruent to 5, that means 3 is congruent to 5. We call that the transitive property. Same thing with 2 and 8. Sorry, angle 3 is congruent to angle 5, and angle 2 is congruent to angle 8. And the same idea with our exterior angles. Angle 1 is congruent to angle 7. Angle 4 is congruent to angle 6. 1, opposite side of the river, opposite side of the bridge. 1 and 7. Opposite side of the river, opposite side of the bridge. 4 and 6. So those key ideas are going to be properties. They're going to be ideas that allow us to find missing angles rather than just using our algebraic properties. Now, this may look intimidating to start, but it's basically just an idea of how we can find all these angles using these properties. Feel free to pause it right here and see how much of it you can do yourself. But we will obviously go ahead and do this together. All right, some things that are not on here that should be. These two lines are parallel. So those are the markings for parallel lines. When you see those markings, we can say that they are parallel, meaning those are the shores of our river. So here's our water. Here's our shoreline. Here's our grass. Now, the thing is, we have two bridges. That means these four angles are the same as these four angles, and these four angles are the same as those four angles. So you kind of have to, in your mind's eye, ignore one of the bridges and focus on maybe just the red, or ignore the red and focus on just the purple, and see how much of it we can do using that idea. I'll leave those up here for now. So you can fill this out down below just so I don't have to keep zooming in and out. I'm just going to write all of my work up here in the diagram. All right, my piece of advice. I always look for the vertical angles. They are the easiest to spot, meaning if this is 54, this is also 54. So 3 is 54 degrees. And then I always just try and get one set of 4 done. We know that these are supplementary, so they should add up to 180. So 180, if I take away that 54, I'm left with what angle 2 must be. So 180 minus 50 is 130, minus 4 is 126. And 4 is vertical, so 2, so 126. So right there I used the idea of supplementary angles and vertical angles. So I only needed one angle of the 4 to get all 4 of them. And since I have all 4 of those, I have all 4 of those. So really I needed one angle out of 8. Now I'm going to go over to the red. Now notice I had one of them for purple. I don't have any of them for red down here or over here. So I really can't do anything with the red yet. I'm going to go inside here and I say if this is 88, then this is 88. That means this is supplementary. So this is 180 minus 88, which is 92 degrees. So this is 92 degrees. Now, this has nothing to do with these, okay? These are the ones that are attached to the sides of the river, or the parallel lines, okay? This is the intersection of the bridges. I still don't have one of these 4. The only way to get one of these 4, notice, 14 and 8 are the only 2 angles that are connected to something else other than those intersections, and they're connected to a triangle. Okay? They both have a 54 and a 92 in them, and we know that triangles add up to 180. So if they all add up to 180 and we already have 92 degrees and 54 degrees accounted for, subtracting that leaves us 34 degrees. It's the same subtraction up here, so this is 34 degrees, which means this is 34 degrees. This is 180, take away 34. So this is 146 degrees. And the same thing happens down here, 34 degrees and 146 degrees. Notice what we used over and over again. We used the idea of supplementary angles, vertical angles, corresponding angles, and we happen to have triangles add up to 180. If that was a rectangle here, they would add up to 360. And again, that's using that 180 times n minus 2 idea. All right, there's a lot of practice problems to go along with this. I advise you to go over these practice problems, not just your homework problems. If those are some problems you want to do together in office hours, we can, or if you want to try them on your own and then ask questions during your office hours, please practice these. These are going to need a lot of exposure to get used to seeing certain things. Okay, so a lot of vocab in 3.6, a lot of geometry to get used to that we're not used to in our previous algebra classes. So I stress that you practice these problems and then make sure you reach out